Good morning, students. Today we will discuss about the concept of intermediate code generation. The outline of this today's class is we discuss about the phases of compilers. Then after that, intermediate code generation. Then how we will represent that intermediate code. Then after that, three address code. Then in that we have quarter pulse, triples, indirect triples, and finally we will discuss about lab programs, triples. Okay. So first, what do you mean by intermediate code? So here during the translation of a source program into object program, okay, that is object code for a target machine, a compiler may generate a middle level language. Okay, so that middle level language we will call it as an intermediate code. Suppose if this is the source program it may be in C or a C higher level language, and the target program is in a lower level language. That intermediate representation it may be in assembly level language. Okay, so this intermediate representative code is nothing but a intermediate representation of a. During the translation, the source program is converted into object code. At that time, it may generate intermediate language code. That one we will call it as an intermediate code. Okay, so this is the phases of compiler. So in that we are discussing lexical analysis, syntax analysis, semantic analysis. So after semantic analysis, so these three things we will call it as a front end of compiler, and this intermediate code generation, code optimization, and code generation. Finally, these are nothing but a back end of the compiler. So in that back end, this is the intermediate code generation. It will be the first phase. Okay, so this is the fourth phase of the compiler. Intermediate code generation after lexical analysis, syntax analysis, and semantic analysis. Okay, the output of semantic analysis, that is output of that is syntax tree. Okay, so that will be the input to the intermediate code generation. Okay, so this is in that fourth phase is the intermediate code generation in the compiler. Okay, so here how will represent the intermediate code? So here there are commonly used intermediate code representations. There are three types. So using syntax tree and postfix notations and three address code. Okay, so the syntax tree. So we already discussed in previous class in the fifth module. Okay, so that is after that we will have postfix notations. That is conversion of that is representing the infix expression to postfix expression. That is, then after that this is the important thing: three address code. Okay, so we'll take one simple examples on syntax tree, postfix notations, and three address code. Okay, so what do you mean by syntax tree? We already know that the syntax tree is nothing but it is more than a condensed form of a parse tree. Okay, so that is the condensed form of, so that is compressed. It means only important things we are taking from the parse tree. That what we will call it as a syntax tree. The operators and keywords are nodes of the parse tree are moved to their parents to chain of a single production is replaced by a single links in the syntax tree. The internal nodes are operators and child nodes are the operands. So usually in syntax tree, so here that operators will be a parents node. Okay, so then operands will be a child node. Okay, so suppose if you have taken this example, okay, x is equal to a plus b star c. So within the parenthesis, y divided by a minus b star c. Okay, so then if you represent this one in a syntax tree, so that I already told that operators are the root of the nodes and the operands are the childs. So you can take this one. So here x is equal to, so here equal will becomes the root of the tree. So then left that is left side we will have x. So then right side this expressions. Okay, so this expression will be representing a parse tree. So here a plus b star division is there. So this division becomes the root of that right subtree. Okay, so in that division, so one side is this expression and right side will be this expression. Okay, so when you come to left side of this, so here we have a plus. So in that plus a plus b star c. So here we have plus will be the root. So left of that we will have a, and right of that plus we will have star. In that star we have operands b and c are the child of this. So like that here. So when you come to right of this division, so here for this expression, Okay, so for this expression here we have, so minus becomes the root of this subtree, and here a becomes the left child, and here right child will be the star. Okay, star, and b and c are the child of this star. Okay, so here we are not using any grammars or non-terminals. So here we are using only operators and operands. That one we will call it as a syntax tree. We already derived a number of syntax trees. Okay, so next one is postfix notations. We already know that we have converted infix to postfix expression. Suppose if we have a infix expression a plus b, so that is we convert the postfix means the first operand comes after that operator. Okay, so that is the same thing. So we will take one example. Okay, so here suppose if we have a minus b star c plus d plus a minus b. So this is the infix expression. So when you convert this one into a postfix expression, so this one will be a minus b. So that one will be, so a b operands will come first, after that minus, and here c. So within the parenthesis there c plus d. So that is cd plus. Then after that we'll have a minus b. So here AB comes first, after that minus, then after that we will have, so based on the precedence of the operators, so we will convert that one to infix into postfix expression. So then after that here star and plus is there, so plus comes first, sorry, here AB minus, then after that plus comes here, then after that a star comes here. So based on the precedence, we will convert infix to postfix expression. That is the another representation. So next third one is important thing is three address code. Okay, so here a statement, what is the three address code? Okay, a statement involving no more than three references. Okay, so when you are writing a three address code, that statement should only three references. That's why we will call it as three address code. So that is, in that three address code we have two operands and one two for operands and one for result. Okay, so that one we will call it as a three address statements, two for operands and one for results. A sequence of three address statements is also known as three address code. Okay, three address statements we will call it as a three address code. The three address statements is one of the form x is equal to y operator z. So it means here x, y, z will have the address. These are the three memory locations. Sometimes a statement may contain less than three references also, but it is still also called a three address statement. Okay, so a statement it may contain three or less than three. Okay, at that time also we will call it as that one as a three address code. For example, here we have a is equal to b plus c star d. See here in that 1, 2, 3, 4 operands are there. So but here according to that two operands and one result. So but here we have total four operands are there. So that's why it's not in the three address. When you convert this one to three address translation, okay, three address code. So here what we are doing, so here we will divide this expression into sub expression. Okay, so how we will divide this? C star will be first calculated. Okay, so that one C star will be calculated first, and that one will be stored in R1. Okay, so C star S will be multiplying, and that one will be stored in R1. Okay, so intermediate memory, that one will call it as a register. Okay, so here this C star will be calculated, and that one will be stored in R1. So then after that whatever result I am getting, that one will be added with B. So that is, so B plus R1. So that one will be stored in result R2. Okay. So then finally this whole thing result will be copied to A. So that is whole thing is result is available in R2. That one will be copied to A. Okay. So that one we will call it as a three address code. So it means we are converting maximum two operands and one result. Okay, so that one we will call it as a three address code. So here in three address code, we are having two different forms of representation. Okay, a three address code has at most three address locations to calculate the expression, maximum three address locations. Okay, so here this three address code can be represented in two forms. That is, one is quadruples and another one is triples. So in the triples we will have indirect triples. Okay, so then how we will represent this quadruples? What do you mean by quadruples? So here in quadruples, each instructions in a quadruples representation is divided into 4 fields. One is operator, another one is argument 1, another one argument 2 and result. So 4 things. That is, one is operator, another one is argument 1, another one argument 2 and result. Okay, for example, here we have taken same example, R1 is equal to C star D, R2 is equal to B plus R2, then R3 is equal to R1 plus R2 and R3 A is equal to R3. So here in this first expression, R1 is equal to C star D. So here star is the operator and C and D are argument 1, argument 2 and R1 is the result. This is the representation of quadruples. Okay, so like that here in the second statement, so plus is the operator. Okay, so then B and R2 will be the arguments. Okay, B and R2, sorry, R1 this is. Okay, so B1, that is R2 is equal to B plus R1. So that is B plus R1. So that one result will be stored in R2. Okay, so then R3 will be addition of R1 plus R2, that is R1 R2, argument 2 R1 R2 and argument 2 is R1. So when I add these two things I will get R3. Okay, so then finally A is equal to R3. We already told that, so it may contains a less than 3 operands also. So here we have that is result will be A. Okay, so result will be A and this one will be R3, argument 1 will be R3 and operator will be plus. Okay, so like that we will represent the quadruples. Okay, so now come to triples. So here in triples, quadruples it has 4 fields. In triples it has 3 fields. So one is for operator. Okay, so another one is argument 1, another is argument 2. 3 things: operator, argument 1, argument 2. Yeah, so operator, argument 1, argument 2. So the same expression, how we will represent that one in triples? Okay, the result of respective subject expressions are denoted by the position of the expression. Okay, so it will be, the result will be represented by the position of the expression. So here, first one is R0 is equal to C star D. Okay, so first one is R0 is equal to C star D. So here argument 1 is C, argument 2 is D. Okay, so we have added 2 things. So the multiplication. So operator is multiplication. So that is C star D. So argument 1 is C, argument 2 is D, and operator is star. It is multiplied, and that result is stored in memory. That is position of the expression. So position of the expression is 0th. So it means in 0th locations the result is stored. Okay, so then I am adding that R1 is equal to B plus R0. So R0 is nothing but a memory location. Okay, so this is position of, that is position of the expression. So here 0th position will be added with B. So operator is plus. So 0th will be added with B. That result will be stored in R1. That is R1 is nothing but a memory location. Okay, so here that is nothing but a position of the expression. Okay, so now R2 is equal to R1 plus R0. So here R0, the result will be stored in R0, that will be 0th position, and here this B plus R0 will be result is stored in R1, that is first position of that expression, that is 0th and plus we are adding, that operator will be plus. Okay, so this is the second position. The second position, that result is stored in the second position of that expression. So then R2 will be copied to A. So that is a operator equal and argument is 2. So here the result of respective sub expressions are denoted by a position of the expression, the result only. So then argument 1, argument 2 and operator remains same. That result, that's all. Okay, result will be represented in the form of expression. Okay, that one we will call it as a triples. Then last one is indirect triples. So here indirect triples, what we are, so here position of the expressions or sub expressions we are using in triples to represent the result. So here in indirect triples, this representation is an enhancement over the triples representation. It uses pointers. See here, it uses the pointer instead of position to store the result. Okay, so pointer, that's why we are calling as indirect triples. This enables the optimizer to freely reposition the sub expression to produce an optimized code. So here in this triples we are using a position of the expression. So here it will use a pointer instead of positions. That's why we are called as a indirect triples. We will take an example on this. Okay, so here in exams they may ask translate the following expressions to quadruples, triples, and indirect triple. Okay, so this is the expression they have given. Okay, so A is equal to B into minus C plus B into this is nothing but a in multiplication symbol, and B into minus C. Okay, so here, so this is not in a triple form, triple address code. So we need to convert first one is triples. Okay, so here how we will convert this one. So here this minus C, I am taking this is a minus C. So we don't have here two operators, two operands for this. Okay, so this is an unary operator that is U minus, unary minus. Okay, so C, unary minus C. Okay, so minus, that is unary minus, this is the C operand. So this one will be stored in T1. Okay, so then after that T2, that is B into minus C. Okay, so minus C is nothing but a T1. So here T2 is equal to B into T1. Okay, so B into T1. So this one we are taken. Then T3 is unary minus C. Okay, so this is the 3. Okay, and T4 is equal to B into T3. Okay, so here B into minus C and B into minus C. Okay, so 2 times we have taken. Okay, B into T3. So that one will be stored in T4. So then after that, okay, so after that what we are doing here, then we need to add these two things, B into minus C plus B into minus C. So this one will be the T2. Okay, so whole thing will be the T2, and here it will be a T4. Okay, so I am adding T2 plus T4. Okay, so this is T2 and T4. So I am adding these two things, and that one will be stored in T5, and finally the T5 value is stored A. So this is the representation of 3 address code for the given expression. Okay, in exams they may ask they will give the expression and represents the 3 address code. So then you need to write this one. Then how we will represent that one in a quadruples. Okay, so same thing. So here in quadruples we have 4 things, that is operator, argument 1, argument 2, and result. Okay, so this is the location. If you want you can write it, otherwise this is for a quadruples it will be enough. So here, so first one is T1 is U minus unary minus C. So here operator is minus U minus, okay, argument is C, and result will be stored in T1. Okay, so then T2 is equal to B into minus 1. Okay, so T2 is equal to B into minus 1. So here B and T1 are the arguments, B and T1 are the arguments, and result is stored in T2, and this multiplication is the operator. Okay, multiplication is the operator, and B and T1s are the arguments. Okay, B and T1 are the arguments, and this is the T2. Result will be T2. So then T3 will be, okay, so unary minus C. Okay, so unary minus C. So the operator is the U minus, and the argument one is C, and result will be stored in T3. Okay, so then T4 is B into T3. So T4 is equal to B into T3. Okay, so the operator is multiplication, argument is B, and argument 2 is T3. So then result will be stored in T4. So then this T5 is equal to T2 plus T4. This T2, T4 are the arguments, and plus is the operator, and T5 is the result. Okay, so then A is equal to T5. So equal is the operator, and T5 will be the argument 1, and result will be stored in A. So like that we are representing a quadruples. Then when you come to triples, okay, so here in the triple representation, so here we don't have result. The result will be stored in the location one, that is position of the string, position of the sub expression. So here operator is equal to unary minus, okay, first one u is t1 is equal to u minus c. So here argument one is c. So this is triples, operator, argument one, argument, result we don't have. Okay, so then that one will be stored in the location 1. Okay, so in that location 1, then next one t2 is equal to b into t1. So t1 is nothing but a location 1. Okay, that is the argument 2, and b is the argument 1, and we are multiplying with, and that result will be stored in location 2. Okay, so then in when you come to location 3, that is u minus c. U minus c will be the unary minus will be the operator, and c will be the argument 1. That result will be stored in location 3. Okay, so then t4 is equal to b into t3. Okay, so result will be b into argument 1, and t3 will be the location 3. Okay, so those things should be multiplied with operator multiplication. Okay, so then that one result will be stored in location 4. Then here t5 is equal to t2 plus t4, that is location 2 and location 4 are adding. So that one this that is location 2 and location 4 are the arguments of these two things, and adding those two with the operator plus, and it will be stored in location 5. Okay, so that is the thing, location 5. Then the content of location 5 copy to a. The content of location 5, so here argument 2 is nothing but a 5, and argument a is equal to 1. Argument 1 is a, and operator is equal. Okay, so these are the, like that we will represent the three address triple representation. Okay, so then last one is indirect triple representation. So here we are using pointer, that's all. Okay, so this is nothing, everything is this is a triple representation, whatever we have discussed, whatever we have discussed this one. Okay, same thing we have used. Okay, so triple. So here what we are, these statements we are using a indirect address. So that result will be stored in 35 point, this is a pointer. Okay, so the pointer holds the address of statement 1, address of statement 2, address of statement 3, address of statement 4, address of statement 5, address of statement 6. Okay, so here this pointer holds the address of statement 1. This is that is location 1. Okay, so this comes. Then when you come to this one, we will have this operator and argument 1. So that is nothing but an indirect triple representation. Same thing. So we will have that pointer. Okay, that pointer contains the address of another variable. Pointer is a variable, it holds the address of another variable. So this is the pointer, it holds the address of this location 1, like that. This is indirect